In number 32, they give you two functions for Jacob and Jessica. Jacob is represented by the following. Jessica is represented by g of t. They want you to evaluate after 5 weeks. So since t is weeks, I'm going to plug in 5. So I have 8 times 2 to the 5th. 2 to the 5th is 32. 8 times 32 is 256. G of 5 equals 2 to the 5 plus 3. I evaluate those first. 5 plus 3 is 8. I get 256. It says to base on the growth function from both functions explain the relationship. Well, f of t and g of t are the same function. You could basically mention they're the same function because they're both the same amount of dandelions, but if you wanted to go one step further, here's why they are. I take my f of t function and I rewrite 8 as 2 to the third power. 2 to the third power is 8. Well, when you're multiplying like bases, you add the exponent, so I get 2 to the 3 plus t. And because of the commutative property of addition, I can turn that around and say 2 to the t plus 3, which is the same thing as g of t. Here is an official proof of why they are the same. For number 33, I see that I'm dealing with a parabola, dealing with an object above the ground. It looks like a projectile of some sort. So what I do initially or right away is I put this in my calculator. Now, the only problem is that when I graph this, most of you are going to have this standard window, and it's going to be very hard to see. So what I notice is that this is probably some type of rocket that went up in the air and then went down and landed somewhere. Okay, and this is obviously your x-axis and your y-axis. So if you notice, it looks like we're going from 1, 2, 3, 4, 5, somewhere around 5 of my x values. This rocket goes really high, or whatever this object is. So let's take a look at how high it goes by going to my table, hitting second graph. I scroll through. It looks like the highest point is about 144. So what I'm going to do is go to my window, and I'm going to change my minimum, my slowest x value to 0, my highest x value to about 6. It crossed the x-axis at 5 seconds. A rocket can't go into the ground, or this object can't go into the ground, so I'll change this to 0. And that maximum height was 144, so I'll say 150. Just so I can see the picture to look like this. It says, determine the number of seconds it takes to achieve its maximum height. It says justify your answer, and it does not say algebraically. So what I'm going to do is I'm going to go to my calculate menu by hitting second trace, hitting enter on maximum because I am looking for the maximum point. Okay, so I move my cursor to the left of the highest point. Now it's asking you for a boundary on the right. I move my cursor on the right, and then I move my cursor in the middle somewhere and hit enter for a guess. It returns my highest point to be 1.99999. You can call that 2. So the highest point, or the maximum height, is 144. The x-axis represents time, and the y-axis represents, or the y-point represents height. So after 2 seconds, the graph or the object reaches its maximum height. Now it says justify your answer. You're going to say, I used the maximum command on my calculator. I know it seems silly to say that, but we need to know as graders how you got your answer. A complete sentence shows us that you know what you're doing. State the time interval in seconds during which the height of the object decreases. So technically this object, it's going up and then it's going down. It's going up until it reaches that maximum height, and then it's going down. So from this x value to this x value, we need to know what values of time. Well, from this section, we know that at 2 seconds, it's reached its maximum height. So now what you have to find out is that point. Going to my equation and then going to my table, I notice that my graph hits the ground a height of 0 at 5. So I'm going to say from time equals 2 to time equals 5, the graph is decreasing because at time equals 2, it's at its highest point, and at t equals 5, it's on the ground.